Okay. Okay. So I'll give you an example of demand equation. So example here, say P1 equal to negative 2.5 plus 100. Say P2 equal to negative. Okay, here is Q. I forgot to put the Q. Negative 10 Q plus 350. Say P3 is equal to negative 5.6 Q plus 299. So this is an example. So what you do, you just practice, how to sum the demand function. All right? Okay. So let's continue with our discussion. Now, we were talking about the partial public good, the grazing field example, or more generally, the good that have one character of public good, and it is rival, okay, non-excludable. So it's the terms they use in the book is contestable public good. So our example was the grazing field, and other example would be bridges, road, road connecting 2 points, the whole highway. But sometimes during Hari Raya, or New Year or Deepavali or holiday, our road highways, the whole highway, from Kuala Lumpur to Alustar, then, or from Kuala Lumpur to Kota Baru, jam sampai Kuala Krai. Right? So that is a kind of congestible public good. All right? Okay. Now let's look at the model on how to overcome or reduce the problem of congestion. And we did discuss last time, one way is what? One way is to put a price, okay, or toll. Example, the parking, okay? Parking lot. So parking lot is another example, it's a good example. To reduce the congestion, we charge price. And similarly for bridges. For Penang Bridge or highway, Karak Highway or East Coast Highway, Plus Highway, no charge toll. All right. Okay, now that is a way to reduce congestion. Now, first thing that you need to understand is the concept of marginal cost as a function of number of users. Now, what we have done, okay, we understood the marginal cost. Marginal cost we discussed so far is a function of output level. Okay, that is production cost. Okay, that's production cost. But here, we are talking about the marginal cost as a function of what? Function of n. That is the number of users. N, that's the number of users. For example, bridge, that means the number of drivers or number of vehicles. All right. So now we are looking at the marginal cost as a function of number of users, because it's a public good. Public good, everybody can use it, same quantity, okay? Everybody can use the same quantity. So the marginal cost as a function of n, how does it look like? It will be just equal to 0. This is n, that is marginal cost, or you can put 0. So the marginal cost as a function of n, so you have to differentiate. It's just equal to 0. So marginal cost is 0. So marginal cost as a function of n is equal to what? 0. So in other words, if I provide the good for one person, that means if the second person use it, or the second person consume it, is there additional cost that I incur? No, 0, because the good has already been provided, right? The good has been provided. So to provide the good for additional number of users, there is no additional cost because the good is already been provided. Example, the bridge. Okay, the good is already being built. Okay, it's already been built, provided, and one driver use it, one car, and then you have second car using it. Is there any additional cost? No. Okay, because the good is being provided. So third car and so on. So the marginal cost as a function of n is equal to what? Equal to 0. So make sure we understand the concept. The concept here is what? Function of n. The production cost, function of the output level. So that's the difference. Okay. So for public good, once the good is provided, to have one more person consume it, the marginal cost is 0. Okay, there is no additional cost. All right. Everybody understand? Okay, that's number 1. Number 2, for the rival public good, for this partial public good, non-excludable rival, okay, non-excludable public good, we call it congestible public good. Congestible public good. There will be what? There will be congestion. So you have your congestion. Congestion, just like the grazing field, congestion after a certain number of users, say n star, correct? So that means there is congestion. So there is what? There is a marginal congestion cost. Marginal congestion cost. Marginal congestion cost. Just like external cost. Okay. Congestion cost is not just cost of production. It's cost to you, to us. Okay. To the people who are involved in the congestion. Marginal congestion cost, we call it C prime congestion cost. C prime N. Okay, so congestion cost is, we call it Cn. Okay, that's congestion cost. And the derivative is C prime N, the marginal cost, marginal congestion cost. So it's just like externality cost. So here, it's not just cost that can be monetized. Okay, certain costs, it's more psychological. All right. Now, what are the congestion costs that you may incur? Suppose you are stuck in Karak Highway, nak balik Gayu, jam from Gombak to Bentong 3 jam. What are the congestion costs that you may incur if you are driving with your parents, or you are driving your own car? What are the congestion costs?
Time.
Time cost. Okay, that's time cost. 3 hours. What's your time? What is the value of your, of your time? So that's one. What is the other one?
Petrol.
Petrol. Okay, petrol is direct. Petrol, and then wear and tear to your car. Your car is on for 3 hours, aircon on, suddenly boom, meletup, pecah habis engine. So that is wear and tear to the car. And what? And the one that cannot be monetized, apa dia? something that you don't
Emotion.
emotion. Okay, your psychology. You can get gila, you can become crazy because of your, let's say you are married, you have a daughter or son crying, suddenly you get mad, so that is psychological cost, and those are things congestion cost. So the marginal cost of marginal congestion cost would be positive. After n star. Okay. After n star, you will incur some congestion. That means we incur congestion cost. So in terms of the diagram, there will be what? Positive congestion, positive marginal congestion cost. Okay. All right. So let's say we think that as n increases, the C prime of n 2 point increases. So how do we put it on the diagram? Okay, so that's the idea. Okay, the idea is congestion up to a certain point, there is no congestion. Everything is good. But after that point, okay, after a certain point, n star, there will be congestion. So everybody will incur congestion cost, and we are looking at marginal congestion cost, and C prime n is bigger than 0, and C prime n is increasing as n increases. And of course, up to n star. So how does the diagram look like? Okay, we go back to our diagram. Okay, so suppose n kat sini, ni n star lah. Okay, that's n star. So the MC is equal to 0 up to n star. Say n star is here. And after that, we incur congestion cost. So the marginal congestion cost is what? Is positive. So we can draw it. So C prime n positive. So up to n star, 0. Okay. After n star, we incur congestion cost that is shown by the positive marginal congestion cost. So that is going up. Okay. So curve going up. So you want to draw it straight line, you want to draw it a curve, that's fine. Okay, doesn't matter. So I just draw it straight up. Okay. All right. So if there is no congestion, all right, if there is no congestion, the optimum point, okay, or the efficient point will be what? Will it be here? Suppose that's the demand function or the marginal benefit, and you have your N1. Now, is this the best that we can do? Is this efficient? N1. Redisconnect. Yeah. Okay. Can you see the screen or you don't? I have to share. Take a look. Okay. Okay. Boleh? All right. So now, if D is, say, D1, right? The equilibrium point is N1. Now, is that efficient? Suppose you have D2. So the point intersection N2. So given the demand, okay, D1 or D2, the equilibrium number of users is N1 for D1, N2 for D2. But is this efficient? Either D1, why not?
Not intersect with the marginal congestion cost.
No, that is not the reason. Okay, but you have a good idea. Okay, you have a good idea. But it is not optimum, or it is not efficient. Why? Because if demand is D1, the equilibrium point is N1. We can still add more users, all right, without increasing the marginal cost. So I can still have N2, higher number of users. and the marginal cost is still what? 0. Okay, so N2 is actually what? It's actually better off. Because why? I can provide the public good with more users, but no external cost or no congestion cost. Okay, all right. Now, N2, I ask the same question. Is N2 optimum? Can we add more people without adding cost?
Yes.
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 So where is the last point? The last point will be here. If you draw
And
the
star.
diagram, they must intersect and star. Okay, so mine do not, so I make a bigger dot. So that is our D, and the efficient point will be N star. So for equilibrium, all right, for equilibrium, demand equal to supply. In other words, marginal benefit equal marginal cost. All right, and that will be where equilibrium will be N equal to N star, and MC is 0, because if okay, if N is equal to N star plus 1, then what? Then MC will not be 0 anymore. So the optimum point, okay, the optimum point would be the intersection between the demand and the supply function, or the marginal benefit, marginal cost, or demand marginal cost at the point N star. Okay, it's the last point. Okay, that's the last point before congestion will arise. Okay, that's the last point. Because if I add another percent, then there is what? There is congestion. So we should add MC is not equal to 0, since what? Since now C prime N is bigger than 0. Okay, there is what? There is the congestion cost there. Okay, okay. So that is the efficient point. Now, suppose the demand is very high. Okay, during 8 o'clock in the morning, or during festival holidays, demand increases. So the demand go up to here. So let's say the demand is there. Now this is a different story. Okay, the one that I show here is the efficient point. All right, but now I'm talking about demand has rise, so that the congestion cost is positive. Okay, now when the demand is high such that there is congestion cost, so we have shown by the D function, blue line. So that is, and you have that point of intersection, say point E1. Oh, I call this point E, right? Call point E. And then let's say E1. And that E1, okay, what happened at E1? At E1, of course, the number of N will be increased to N, N1, N2, N star. I call it N3. Okay, so the number of users has gone up to N3. All right. Now, what happened at E1 relative to E? You look at the equilibrium. All right. I already discussed the N. I already mentioned N, N2, N3, and star. Okay. What is the other difference between E and E1?
The price increase.
The price increase. Okay. In other words, there is what? There is congestion. Okay. At E1, you have marginal congestion cost positive. All right. So due to D, higher demand, all right. So let's say demand has increased. Demand increases to D. Okay, I call it D in blue line tu lah. Okay, you just put D. Oh yeah, D, because that is another story than the one that I'm talking about, N1, N2. The increase to D, and then you have the equilibrium E2. All right. The number of users is N berapa tadi? No. Equilibrium is E2, betul? E2. E1 ke E2?
E1.
E1. Tengok balik. E1. Lepas tu, the number of N, N3. Okay, number of N, N3. E is E1. Now, at N3, what happened here? There is congestion. Marginal congestion cost is bigger than 0. And say marginal congestion cost is C prime N3. All right, equal to that thing. So how do you show that marginal congestion cost? So that will be shown by the line, the red line, connecting N3 to E1. So that is C prime N3. Okay. So at E1, where the number of users N3, you have what? We have congestion. Everybody incur C prime N, called N3. Or you can imagine, say 100, get 100 ringgit. We incur the cost, 100 ringgit. All right. As you know, at N star, C prime is 0. There is no congestion. Everybody drive nicely. Okay. But after that, congestion will arise. And you have given the demand function, D, the congestion is given by the marginal congestion cost, C prime, N3, because we label it N3. So suppose it's 100. So 100 ni example je lah. All right. So that we can imagine certain number. Okay, now, how do we reduce the congestion? Because that's like the grazing field example. There's more cows coming in, you have less cows, you have less grass for all cows. All right. So what was our solution? Our solution was, or like the parking lot example, what was our solution?
Toll.
Toll. Okay. So thing is, how do you set your toll? How do you set your price? So to reduce the congestion, we charge toll, charge price. Or here, what is the toll? Call it T. Is equal to what? Is equal to C prime N3. Example, T equal to 100. So the toll, just like the externality, the tax must equal to the marginal external cost. So here, the toll or the tax equal to what? Equal to the marginal congestion cost. Okay? So when you put tax equal to the marginal congestion cost at N3, where the demand is, what happened to your demand function? All right, you go back to the diagram. Mana diagram? Diagram. Okay, you go back to the diagram. If I impose the tax or the toll and C and prime or C prime N3, example 100. Okay, what happened to the demand function? Show me or draw on your diagram the new demand function after we charge the toll. Okay, sketch. You can be right, you can be wrong, doesn't matter. I want you to sketch. Okay, sketch on your diagram. Okay, you sketch. You can sketch up, you can sketch below, or you can sketch anywhere you want. Okay, that you think it's the new demand. So where is the new demand function?
Left.
Left or right?
Left.
The new demand function over here, because if you charge the toll equal to C prime N3, the new demand function will intersect that point N3 on the axis. All right. So your new demand function will be that one. Okay, call it D3. Okay, I got D1, D2, so I call it D3. So the demand function will decrease because of the toll. If we charge toll, there will be less drivers willing to use the good because you charge price. Okay, so in that way, we are reducing the congestion. So the demand function will go down to D3. All right, so intersect here, sini, because you charge the C prime equal to the toll. All right, so toll, if you put there, put toll here, all right, equal to the toll. All right, so what happened now? What is the equilibrium now?
The price decrease.
The price increase. You call it E3, no, E2. So the equilibrium will be here. All right, the equilibrium will be there. And the number of N will, what happened to the number of users? Will go down to say N4. And everybody will pay what? Will pay the toll. The toll is 100. Okay. Oh. We charge and pay toll 100. Kalau ikut diagram ni. Toll. You patutnya toll MC equal to 0. You got the equilibrium here. Sepatutnya the toll should be that one. But you test the toll over there. Okay. So macam mana? Macam mana? Patutnya toll is equal to 100. Alright. So what you do? Probably 100. Tak apalah. That is not the point. Okay, the point is you charge the toll, all right? You charge the toll equal to C prime N3. There will be a reduction in the demand. So you have equilibrium E2. Okay, so the issue of the toll, I cannot capture it here because if I put P at E2, that is not equal to 100. It will be less. All right, it will be less than 100, unless there is a subsidy given by the government. So we pay less than 100. So why the reason? The reason being that because MC is equal to 0 here. Okay, if you have the supply function going up like that from there, then you get 100. Okay, but as it is not. Okay, all right. So how do you get that 100? So for now, don't worry about the toll that we pay, and we just argue, all right? When you impose the MEC, the toll equal to C prime N3, say 100, the demand will increase. No, I'm sorry, the demand will decrease to D4. Okay, so equilibrium will now be what? Will be E4, where N is equal to N3 ke N4 N4 equilibrium E2 En is N4. Equilibrium is E2 and is equal to N4. All right, so congestion will be reduced. It will be reduced, and the optimum point, okay, the new optimum point or number of users will be N4. Okay, so by charging the toll, it's efficient. Why? Because it will reduce the externality, it will reduce the congestion. All right. The only problem is with my diagram. I cannot capture that T is equal to 100. Okay, but we have what? We have the important outcome. Demand will be reduced to D3, and equilibrium will be E2, where the marginal benefit is equal to the marginal cost. Okay, and then you will have N equal to N4. Right? Okay. Okay. Any question? Anything? Any comment? Okay. All right. So that is a problem with congestion. It is optimum to charge toll. Okay. All right. Now we have another type of public good, which is what? Which is non-rival but excludable. You have another type of good, non-rival, but we can exclude people. So one good example of this, classic example, is TV wave or TV channel. What do you call it? TV channel or radio. Okay, radio wave. Now this kind of service or good is a public good. It's non-rival, but it's excludable. Okay, for example, TV. Okay, the TV service that is provided to us is non-rival. Okay, you provide to the whole country 20 million people, or you provide to more people, 50 million, will be non-rival. You will still get the same amount of reception. Okay, but we can exclude people from consuming it. Okay, how do we exclude people from consuming the TV service, TV wave, TV cable?
Straw.
Straw. Okay, you charge a price. Okay, you charge a price. So you charge a price, you exclude people. So in this type of good, when you charge price to exclude, and the good is non-rival, that will be not efficient. Okay, that is on the other hand, the good that we just discussed earlier, a non-excludable rival. You charge price, it is efficient. Okay, but for this one, non-rival, excludable. Your charge price is not efficient. All right, so let's look at the model. So for example, the Astro, the Astro TV thing, actually it's not efficient to charge price. So Astro actually can provide that thing for free, So let's look at the model. So you have here, okay, non-rival. Again here, you have the marginal cost as a function of n, okay, where n is the number of users. So as you can see the diagram, n, mc, 0. Marginal cost is on the horizontal axis. mc equal to 0. It's not rival. There will be no congestion, all right? So it's not like the previous model where you have, after a certain point, you have congestion cost. In this case, whatever the amount, 20 million, 50 million, all right, 10 million, there will be no congestion, okay? Because good is non-rival. And it can be excludable because you can charge a price. So what is the efficient point? Given the demand function, all right, given the demand function, say demand function like that, then what is the equilibrium? The equilibrium is E, yeah. All right, so that E, we call it N star. So equilibrium would be where demand equal supply or marginal benefit equal marginal cost. So we got equilibrium at E. N equal to N star. Price is 0. And C is equal to 0. Okay, that's free. Okay, it's free. Okay, now suppose they charge you a price. Okay, charge as a price. Say price is here. MC equal to P1. So that is P1. All right. When you charge a price, then our equilibrium will be found there. Okay, call it E1. So N is N1. And when you charge the price P1, then what? Then you get revenue. Okay, you get revenue P1 and 1. But that is inefficient. Why? Because your marginal cost is 0. All right, your marginal cost is 0. When you charge a price, what you will get is E1, and that E1 here is inefficient. So for a non-rival good, excludable, you charge a price, it's what? It's inefficient. Just like Astro. Astro should have given us free. Okay? Because the good is non-rival. But for Astro, how can they get revenue? If let's say they give us the Astro free, how could they get revenue? What are the sources of revenue for the Astro? For Astro, not just Astro lah, any other TV company in the world.
Exclusive content.
They have what? They have rights. Okay, they have advertisement. They sell time slot. Okay, so if you look at the revenue from those sources, advertisement, things like that, I think the price that they give us like what, 50 ringgit kan, 50 ringgit a month. I think the revenue they get from other sources will be much higher. All right, and if they give free, every house will have access to that thing. Then what? You access more people. You access more people. Your market is larger. You can sell more advertisement. You can get more, more time, TV time, things like that. You can sell more TV time. You can get better revenue. So that's why we say for a non-rival good, it's to charge a price, it's inefficient. Now, if I still recall, when I was small, masa tu you pun belum lahir lagi. Entah mak ayah pun tak kahwin ni. In the 1960s, 70s, do you know that TV masa tu tak ada lagi, okay? TV belum ada. In the 70s ada lah TV, but in the 60s, early 70s, especially for us in kampung, there is no TV. We have only radio. Do you know that we pay price for radio at that time to the government? Do you know that or you don't know?
No.
Huh? Tak tahu kan? At that time, we pay, okay, they call it TV price. Oh no, radio. They call less than radio. Less than radio. That means a toll for the radio. For 1 year, we have to pay 12 ringgit. But 12 ringgit for people in kampung per year, that's a lot of money. So if you don't have that permit, okay, that if you don't pay the fees, this government officer will go visit our house. They found radio, no lesson, kena denda, or they take your radio. So at that time, we pay actually, we pay for radio, but that was inefficient. Okay, after that, they make it free. And I still remember, in my house, we have a radio. When we heard somebody coming, radio tak ada lesen, but 12 ringgit. For my parents, 12 ringgit is a lot of money. We can buy a lot of food. So what we do, we masuk hutan, simpan dalam hutan, letak bawah pokok. So that's my time. Radio was price, okay, but now radio free lah. But TV is still being priced. So for this kind of good, it's inefficient to charge price. Okay. Any question? Anything? So make sure you understand the difference. All right. For non-excludable rival, it's efficient to charge the price. That is the toll. For the other type of good, non-rival, excludable, it's not efficient to charge the price. So that's why you see here, in many types of good. For example, golf, golf course, golf courses. It's a public good, but as more people coming in, it become rival. So they charge fees. Another example is swimming pool. Some swimming pool, it's not rival, but it's not excludable, but rival. So they charge price to use swimming pool. So those kind of things. So there are so many examples, swimming pool, apa lagi? apa lagi example? Itu kuala tu. But there are so many. Okay, all right. So we go to the book. I think what we did, I already covered the chapter. All right. So chapter number 3 or chapter number 4, we're done. Chapter 4 finished. Okay, starting chapter number 4, I cover most of the chapters. If you go through the chapter, I cover most of it. All right. So you'll be accountable to everything in that. Okay, I'll give you problems for that chapter 4. Okay, problem number 1. Number 2. Number 3. You know what? Probably we can do this. Yeah, I mean, again, maybe even though, to reduce the congestion, you charge toll 100 ringgit. All right. But due to the nature of the marginal cost, it is 0. So our demand function will go down up here. But the toll that we pay, all right, will be this one. So maybe the toll that you pay is less than 100. So that is one explanation. Okay. But the way I discuss it, we really don't talk about how much the toll at E2. We just argue that by charging price equal to the marginal congestion cost, we reduce the demand. Okay, you reduce the demand, and you have equilibrium at E2 and will be lower. So that is our main point. Okay, all right. Nanti saya cek balik. Okay, all right. Any question? Anything? Okay, so that is chapter number 4. Now, what I would like to do, we go to chapter 3. I will go through the questions that I give you and you already submitted to me Sunday. Now, this is the way to do it. I mean, the way to do it according to our class, because I saw a few people follow microeconomic method. But we learn another method here. So I want you to use the method that we learned in the class, right? Not the method that you do earlier. The method you do earlier, okay lah. But we learn another method. So we have to use this method because it is consistent with our discussion, right? Okay. Now, you look at the demand function, supply function. Supply function or the marginal cost, right? Cost equal to P, equal to Q over 5,000. So what you do, if you recall, when you discussed about the demand function, we draw the demand function PQ. Okay, P is the function of Q. And then when you put the marginal external cost, you add the marginal external cost to the price. Okay, so what you do, given the equation in that problem, what do we do? How do you get that this one? How do you get the P equal to Q over 5,000? How do you get that? How do you get that? Kita were given Q equal to what? 5,000 P. So how do I get that thing? So you have to rewrite lah. Okay, you have to rewrite P Q. Itu pun kena tukar lah. Okay. So demand function pun jadi apa? Demand function, then you have what? You write P in terms of Q, then what the demand function becomes? Okay, I want you to write. All right, I want you to rewrite the demand function for those who didn't do it the way that we did here. Because I haven't graded yours yet, but I went through a few. You are using Q function. So now we'll do it this way, okay? Based on consistently on our discussion, okay? All right, you got the demand function, P is equal to what? Okay, rewrite, okay? Rewrite. I have time. So you rewrite that demand function. I want you to find competitive equilibrium. Okay, did you hear me last time? Bagus ni. Sebab I was disconnected. So dengar tak dengar?
Dengar je.
Okay, get the equilibrium. So you find the demand function P in terms of Q. All right. So you have to practice. So what do you get? You will get, I give you only the final form, but you show the work. So you got negative Q over 1,000 plus 400. Betul ke tak betul? You check, maybe I was wrong. Okay, you do the rewriting. Did you get negative Q over 1,000 plus 400? Or you don't? If you don't, I will read mine. Probably I was not right. Betul tak? You dengar ke tak dengar ni? Do you hear me? Or am I? Video mana tak ada? Waduh, recording ada. Okay, you got the equilibrium? Okay, first person who got it, let me know. So,
Yes.
okay, good. Equilibrium, demand equal supply, marginal benefit equal marginal cost. So we can put here marginal benefit. all right, equal to the function. So you work that out. What do you get? I get, right? I get Q equal to 333.33. Did you get that? And now you find the price. Price is equal to 66.67. So that is the competitive equilibrium. Kita kata, kalau tak betul, kita buat balik. So you got the supply function just like that. Okay, so that is MC, supply. That is our marginal benefit. So that is EC. Now, do you get this or you don't? Sama ke tak sama?
Sama.
Okay, good. All right, now, we are talking about externality. And this is what? Negative production externality. So you refer back to the question. There is a negative production externality. So the effect will be what? The effect will be on the supply function. Okay, supply function will be affected. And you know the supply function will shift. So with negative production externality, you have your MSC equal to MC plus what? ME. Okay, I come back here. Now, I saw a few of the work. When you write Q as a function of equal to P 5,000 P, well, our theory is externality theory. When you are looking at externality theory, we are talking about marginal social cost, which is equal to MC, marginal cost, plus MEC. And MEC is equal to what? Equal to 20. Is that right? 20. Marginal cost is 20 and it's a constant. So what is your MSC? Your MSC will be equal to what? Will be equal to MC. MC is Q over 5,000, right? Plus MEC equal to 20. So that is our marginal social cost. And as you can see, the marginal social cost will be up there. MEC equal 20. So here is 0, but now 20. So that's why we do it P as a function of Q, so that will be consistent with our theory. MSC equal to MC plus MEC. Okay. Now, if you use Q function of P, I don't know, you put P minus 20, multiply by the thing. So how do you explain that thing? All right. So this is the way to do. All right. I'm not saying this is wrong. This is right also, but we are going to look at from the externality theory, and this is how you define the effect of the externality on either the marginal benefit or the marginal cost. Okay. All right. So it's the function of Q. So you have the thing. So you do the equilibrium, you will get the social equilibrium. You'll be somewhere there. So you will get ES. Okay. And then of course the price will be higher. The quantity will be lower. Okay. All right. So now find it. Okay, I'll give you 3 minutes, 5 minutes. You do this thing, MSC. So for social equilibrium, you have the MB equal MSC, all right, then equal to Q over 5,000 plus 20, and that is our demand. So can you work it out? Tell me what you get, because I haven't done that.
Q equals to 33330.
330. Betul ke tak betul? Everybody get the same? So 330, 000.
333 330.
333,
330.
330. So 333, 330. Oh, betul gitu. Cek.
I get Q equals to 316,666.67.
Okay, 316,
666.67.
666.67. Siapa nama? What is your name?
Azim.
Azim. Okay, yang dapat 330 tadi siapa? What is your name? 330?
Charvi.
Shavi.
Yes.
I think you try again. I think 316 make more sense because the reduction is about reasonable. In your case, you got 333, 330. It only reduced by 3.33. So probably, somewhere you make an error somewhere. Do it again. So Q over 5,000 plus 20, all right, equal to the marginal benefit. Negative Q over 1,000 plus 400. I think maybe somewhere you commit an error. Okay, kita try balik ya. Tak apa. You redo at home. Okay, you do at home. Azim, the price, what is the price? Price at 316, so berapa price dia?
Um, 83.33.
83.33. So I got PS equal to 83.3, QS 316,666.7. Okay, I think this looks reasonable. So, Chaf, you check balik check balik your work. Okay, so that will be the social equilibrium. So the next part is you want to find the market price, the competitive equilibrium we have found, and then you just describe the competitive equilibrium. Now, what is the efficient amount of paper? The efficient amount of paper is this one, ni part B. All right. So the efficient amount of paper, I'm sorry, ayolah sini. Efficient amount of paper is the social equilibrium. All right. So that is the efficient. So the efficient will be QX equal to that amount, PS equal to 83.33. Okay. All right. How can a corrective tax achieve efficiency? Okay, how can the efficient tax, how can the corrective tax achieve efficiency? You set what? By setting the tax equal to MC. So that will give you efficiency. Okay? So M is equal to 20. Yeah, you know what? MEC is equal to 20. You should put also I didn't put. So we must understand that you input x t, okay, equal to NEC equal 20. So that is the thing. Okay. So the tax, in order to achieve efficiency, you must set the tax equal what? Equal to MEC. Okay. All right. Because our efficient condition is this one. Okay. And then you got the equilibrium like that. Now, if you import the tax, we must get the same point. Okay. That is the efficient point. How do you get the efficient point by the tax? Our tax must be equal to MEC. All right. So to achieve efficiency, the tax must be set equal to MEC. Okay. All right. Any question? And you can also do other things actually from that question. You can find, okay, you can find the tax revenue. Okay. And then and that tax revenue will be equal to the external cost. Okay. And then you can find the net gain. Okay, the net gain is that area. So given the line are straight, you can compute the value. Okay, so you can find the net gain. Net gain is that area. So these are additional things that we can do. So you got you label diagram. Okay, label diagram like that. So that is question number 1. Now the important part here is the way we do it. All right, to be consistent with our discussion in terms of activity, we have to do this. Price must be in terms of Q, so that we can make adjustment either for the marginal social benefit or the marginal social cost. Okay, all right. Any question? All right. So I want you to do question number 2. Now, question number 2, I want you to discuss with your friend. Problem number 2. Now, problem number 2, you have the table given there, and you have the marginal benefit. So this is the positive consumption activity. So question 1, negative production. Question 2, positive consumption. So from the table given there, you can do 2 things. Okay, there are so many things that you can do. Number 1, you draw not so nice, just draw it based on the numbers. The marginal benefit, that is the demand function. And then you can draw the marginal social benefit. I'm sorry, not marginal cost, but it's benefit, which is equal to MB plus MEB. Okay, and you can see the change, and then you answer the question. All right, so draw the demand curve, and then supply perfectly inelastic. So supply perfectly inelastic. What does it mean? Marginal cost equal 25. So how does the marginal cost equal 25 look like?
Horizontal line.
Horizontal line. Okay, so the supply is horizontal. So you determine the equilibrium. Social equilibrium, competitive equilibrium. All right. So that question 2, you don't have to submit to me, but I want you to do it. Okay, just practice so that we know how to do that. So that is question 2, and this is homework. I need homework. Okay, home. All right. Okay, good. Now, question, go back to chapter 4. Chapter 4, we are done. Did I give you question 3? Dah bagi dah kan? Question 4, I dah bagi. So, question 4 pun practice lah. All right. And the article, the Islamic perspective article, I will put in classroom ke WhatsApp ke tengok lah. Alright, but those are the 3 articles that is relevant to what we have discussed so far. Okay, alright. Now I'll give you another homework. This is Islamic homework. Now, can you find a hadith or Quranic verse on externality? Okay, on externality that relate to externality problem. Right. So anybody who found or who get that ayat ke hadis ke, you know, share with us on Monday. Okay, this one you can work together. You can work the whole class. You know, you don't have to work within your group. You can work the whole class. Come up with 1-2 ayat or hadis, and then Monday share with me. Okay. All right. So this is another homework. So we can give you quite a lot of work. So you have to start working. Right. Okay. Any question, anything? Now, I may end the class more than 12:45. Why? Because we don't have any more class, right? 1 o'clock, the class, that's your break time. So probably, you know, I will end it after 12:45. So I just, you know, I just need to finish certain things. So I may take a little bit long time. I hope it will be okay with you. Okay, kita okay? Like hari ni, saya ambil 5 more minutes. Okay, last time pun I ambil 5 minutes. So we will take a little bit longer. Right? The reason being because after 1 o'clock you don't have any more classes. Nak makan pun tak makan. So okay, 5 more minutes or maybe 10 minutes depending on. All right. Okay. Now I'll see you again next week, Monday. Okay? Anything? Any question? Any comment before we go? All right, good. So have a nice weekend. Take care. And do the work. Okay? All right. Assalamualaikum warahmatullahi wabarakatuh.
Sir,
Yes.
I want to ask something. For the whole Ramadan, do you plan to have online class?
Online class.
Sampai habis Ramadan ke?
Tak tahu lah. Do you want to? Because now the problem that I face now is that my cucu in my house, one of my cucu, you know, one of my son tested positive, but of course level 1, yeah, all right, and I'm the same household, so I cannot meet you face to face, okay, because of the SOP. So they finish the quarantine maybe next week, okay. Now when they finish the quarantine next week, normally we will give another week, you know, another 7 days to really be, you know, be free of the possibilities. So if we have a face-to-face, probably another week, you know, next week, most probably online, okay, depending on how long my children will, you know, still have this thing. So next week will be still online. The week after that, We have to discuss. Do you want face-to-face class in Ramadan or you don't want?
Um,
Huh?
Honestly, I prefer to be online class
You
because
prefer?
other subject also have online class for the whole Ramadan.
So that is the thing. It's not that, but to me, I like it one face-to-face, one online, but now because of the external uncontrolled factor, we have to do more online. If we do on class, maybe the last week of Ramadan, but we can do it all the way online, for Ramadan. We come back after Raya, then we meet face to face. So that is another possibility lah. Okay. So online probably another week lah, not this week, next week. After that, I yet to see, if next week katakan clear, I still have to give a few more days, according to the SOP before I meet other people. So hopefully by the time okay lah. But if you prefer online, okay je, we do online for more weeks. That's okay with me. All right. Okay. Any other things? Okay. Okay. So I'll see you again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you, sir. Selamat
Okay.
Thank you,
bertugas,
sir.
Oh. To last night Liverpool menang. Oh, maybe you don't like Liverpool.